Hi, this is Rem Jimenez from New Jersey City University, and I'm here to talk to you today about how to run an ANOVA in SPSS. When you look at some data, and let's say you're looking at student data, GPAs for a particular college, we'll call it Blue Skies College, and you're comparing the mean GPAs across different groups, in this case, freshmen, sophomores, juniors, and seniors, one question that may arise is there a difference between the student GPAs and what year they are in terms of college? Well, because we're dealing with multiple means, we need to run a one-way ANOVA in SPSS. And because we are dealing with, in this case, 4 groups, 4 different means, in the form of our independent variable, the student year, we have one GPA dependent variable, all because we're dealing with multiple variables and because we're dealing with, in this case, 4 different means. An ANOVA is a much more appropriate statistic versus a t-test. So in order to get to our ANOVA analysis, let's actually go to SPSS. And I'm going to pull up a data set that I created. A couple things to keep note of. I created the following data set, looking at both, in this case, for individual students, I identified them as either being a senior, sophomore, first year for freshman, or junior. And I took their GPAs. And what I wanted to understand is there any kind of difference between the means of all seniors, all sophomores, all juniors, freshmen, etc. Now, the one thing that I had to do once I put my data together is I had to create this new column called school year. The reason is when I ran an ANOVA, the fields that were not numeric, in this case, such as my year field that I have in the first column, that's pure text and not numeric. When I tried to run the ANOVA, I could not get the ANOVA analysis to recognize this, so the way around it is to make sure that you use numeric values. So I simply went in and assigned a 4 to seniors, a 3 for juniors, a 2 for sophomores, and a 1 for freshmen. So the 2 columns that I'm going to be using for my analysis of variance, or ANOVA, is the GPA column and the school year. And the way that you do this is you go up to the Analyze tab at the top of the screen, go down to Compare Means, and then scroll over to the bottom and choose One-Way ANOVA. In a moment, you'll get your ANOVA dialog box. And in your dialog box, I already have it selected, but we have the GPA. I'm just going to bring these back so that you can see what this looks like. But you would get your fields on the left. So I'm going to put my dependent variable, my GPA, on the left, and put my school year into the factor field below. The factor field is where you're going to put in your independent variable. In this case, the school year, or your groupings, if you want to think of it in that way. Unlike the t-test, you have to take a couple of extra steps. First thing I'm going to do is go into the post hoc button. And when I click on it, what I'm going to see is that I have a couple of different options, including the significance level that I'm choosing for my test, which by default will be set at 0.05. I'm going to make sure that I choose 2 key, because I am assuming equal variances in this case, and choose continue. The other thing I'm going to do is click on the options button. And in this particular example, I had already selected all of my descriptive statistics, my homogeneity variance tests, the Brown-Forsyth and Welch tests that can be used to further calculate any variances, as well as the means plot, which will actually give me a plot of my means and give me a graphical representation. In this case, I'm going to include all the checkboxes that you see here, including I'm going to make sure that exclude cases analysis by analysis in terms of missing values. Make sure that's selected. Once you do that, click on Continue. Once you have those options selected, click on OK. And within a moment, what you're going to have is your ANOVA analysis generated. Now, there we go. I'm just got to go up a little bit here. Beautiful. Here we go. One-way ANOVA. Beautiful. So what am I looking at? Because when you get your one-way ANOVA, with all the options that I selected, I get a descriptive section, which shows me that for each of my groups, it shows me the N that it calculates for my total population, my N of 49. I can see what my N is for the group 1, 2, 3, and 4, as well as the means or the averages for each of these groups, as well as a standard deviation. As I scroll through this, I could see the test of homogeneity of variances. And in this case, I see that my significance factor, my p-value, happens to be equal to 0.005, which is less than 0.05. Therefore, right now in terms of my variances, there is statistical significance. However, as I begin to scroll down into the ANOVA section, I begin to see what the differences are between groups, within groups, and I can see what my degrees of freedom are, as well as my F statistic of 1.14. I see that I have a p-value of 0.342. Now this value, however, although there was significance when it comes to my Levine's test, when it comes to the difference in the variances, I can see that 0.342 more than likely shows me that my ANOVA, my F statistic, happened more by chance, because my significance score was set at 0.05, and 0.342 is definitely significantly larger than my p-value of 0.05. So this occurred more likely by chance and has no statistical significance. I can get further validation by looking at my robust tests of equality of the means, looking at the Welch and Brown-Forsyth statistics. Again, I can see that my p-values here are also greater than 0.05, which also indicates that this did occur by chance, or that more than likely occurred by chance, and has no statistical significance. Finally, I get to go through my post hoc tests, and I can actually begin to see how each of my groups compares to the other. And I could see what the significance level is across the board. As you can see here, the significance level is not significantly statistically significant across the board, because all of my significance levels are definitely greater than 0.05. And more importantly, as I scroll through this list, I get to see the homogeneity subsets lists, which really just shows me what the means are, the subset for the alpha, which happens to be, again, my significance level of 0.05, and a significance level below of 0.318, which again is greater than 0.05, which shows no statistical significance. And finally, although I do see some big variances between the school years in terms of the graph, just because you see big visual representations in terms of differences in your graph or plot does not necessarily mean that that's really the case. You have to really go back and look at the numbers, in this case your p-values, to really understand, is there significance or not. Thank you for attending this session, and I hope you learned a little bit more about what an ANOVA does.